In this lesson, we're going to focus on solving quadratic inequalities. So let's get right into the material. Let's say if we have x squared minus x is greater than or equal to 12. What is the solution? Now, when dealing with an equation, x is equal to a specific number like 4, 7, -2, 0. But when dealing with inequalities, x is equal to a range of answers. And so we have to take a different approach. Now, the first thing we need to do is get a 0 on one side of the inequality. So let's subtract both sides by 12. X squared minus x minus 12 is greater than or equal to 0. Now we can factor the expression. So we have a trinomial where the leading coefficient is 1. How can we factor this trinomial? We need to find two numbers that multiply to the constant term -12 but add to the middle coefficient -1. And those two numbers will be -4 and 3. -4 times 3 is -12, but -4 plus 3 is -1. So to factor it, it's going to be x minus 4 times x plus 3. Now, if we set each factor equal to 0, there's 2 points of interest that we need. If we add 4 to both sides, we can see that x is 4. And if we subtract 3 from both sides, x is -3. So let me write that. X can be 4 and -3. And the reason why it can equal those numbers is because here it's greater than or equal to 0. Now, we need a number line in order to get the right answer. So we have -3 on the left and 4 on the right. At the end, on the right side, we have positive infinity and negative infinity on the left. Now, since the solution includes 4 and -3, I'm going to put a closed circle at those points. If it doesn't include those points, you need to write an open circle. Now, the solution, well, the product of these two factors has to be greater than 0 or equal to it. So we need to check these three regions to see when this side of the equation is positive. We don't want the part where it's negative because it has to be greater than 0. So we got to plug in numbers and test the signs. So let's pick a number between 4 and infinity. Let's try 5. So if we plug in 5 into this expression, 5 minus 4 is positive. 5 plus 3 is positive. When you multiply two positive numbers, it will give you a positive result. Now let's pick a number between -3 and 4. 0 is a good number. 0 minus 4 is negative. 0 plus 3 is positive. A negative number times a positive number will give you a negative result. So let's put a negative sign. Now let's try a number between -infinity and -3, like -4. -4 minus 4 is negative. -4 plus 3 is negative. And so if you multiply two negative numbers, it will give you a positive number. Now notice that the multiplicity of the first 0, 4, is 1, and the multiplicity for the 0, -3, is also 1. Whenever the exponent or the multiplicity is odd, the sign will change at that point. So if you know the first sign, you can easily determine the rest. So for this 0, the multiplicity is odd, so it's going to switch from positive to negative. And for this 0, the multiplicity is also odd, so it's going to switch from negative to positive. But if it was even, it won't change sign. So that's something to keep in mind. Now, we're looking for the region where it's positive. So we need to shade this region and the region on the left. So to write the answer using interval notation, it's going to be a -infinity to -3. Now it includes -3, so we need to use a bracket instead of parentheses. And then union for the second part, it's going to start back up at 4 and go to infinity. So as an inequality, you can write the answer this way. You can say not x is less than or equal to -3, and then you can write or x is equal to or greater than 4. So you can represent it using interval notation or using inequalities. And that's it. So that's how you can solve a quadratic inequality. Let's try another example. So let's say if we have x squared plus 9, and we're going to say that it's greater than 6x. Go ahead and try this. So we need to get a 0 on one side of the inequality. So let's subtract both sides by 6x. So it's going to be negative 6x on the left side. Now we need to factor. Two numbers that multiply to 9 but add to the middle coefficient negative 6 is negative 3. So it's going to be x minus 3 times x minus 3. Now because the two factors are the same, this trinomial is known as a perfect square trinomial. So we can write it as x minus 3 squared, since we have two of them. So if you set x minus 3 equal to 0, you'll get x is equal to 3. So we have one point of interest with two boundaries. Now, notice that it's greater than 0 but doesn't equal to 0. So therefore, at 3, we have an open circle, not a closed circle. So let's pick a number between 3 and infinity. If we plug in 4, 4 minus 3 is positive, and if you square a positive number, it will give you a positive result. Now notice that the multiplicity is even. So as we go across this 0, that is 3, the sign will not change. So then it's going to stay the same. On the left side, it should be positive. And to test it, let's say if you plug in 2. 2 minus 3 squared. 2 minus 3 is negative 1, but when you square negative 1, you get a positive result. So it's always positive except at 3. At 3 is equal to 0. We only want the solutions where it's positive. So we need to shade the left side and also the right side, just not the middle. So therefore, we can write the answer in interval notation as negative infinity to 3, not including 3, union 3 to infinity. So as an inequality, we could say that x is less than 3 or x is greater than 3, but it doesn't equal 3. So that's the solution for this particular quadratic inequality. Now, let's move on to our next example. So let's say that 2x squared is greater than x plus 6. Go ahead and try that. So let's move the x plus 6 from the right side to the left side. So on the left side, they will be negative. Now we need to factor this expression. So how can we factor a trinomial where the leading coefficient is not 1? First, you need to multiply the leading coefficient and a constant term. So that will give you negative 12. And then you need to find two numbers that multiply to negative 12 but add to negative 1, which we already know is negative 4 and positive 3. Now what we're going to do is replace the middle term, negative x, with negative 4x plus 3x. So notice that negative 4x plus 3x is still negative x. So the value of the left side of the inequality remains the same. Now let's factor by grouping. So in the first two terms, take out the GCF, which is 2x. 2x squared divided by 2x is x. And then negative 4x divided by 2x is negative 2. Now in the last two terms, take out the greatest common factor, which is 3. 3x divided by 3 is x, negative 6 divided by 3 is 2. And then at this point also factor the GCF, which is x minus 2. So if we take out x minus 2 from the first term, what we're going to have left over is 2x. And if we take out x minus 2 from the second term, we're going to have a 3 left over. But that's going to be plus 3. And so that's how we can factor this expression. So let's make a number line. And if we set 2x plus 3 equal to 0, and if we subtract by 3 and then divide by 2, the first point of interest is going to be negative 3 over 2. And if we set x minus 2 equal to 0, the second point of interest will be 2. Now keep in mind that the inequality doesn't have an equal sign, it's just greater than 0. So therefore we're going to have an open circle at these 2 points. Let's not forget infinity and negative infinity. Now, which region do we need to shade? First, let me get rid of this stuff. So let's plug in a number that's greater than 2. So let's try 3. 3 minus 2 is positive. 2 times 3, which is 6, plus 3, that's positive as well. So the right side is going to be positive. Now the multiplicity of each 0 is 1, so the signs will change. So here's going to be negative, and then it's going to be positive again. Now we want the parts where it's greater than 0, so when it's positive, that's in this region and in this region. So therefore the answer in interval notation is going to be negative infinity to negative 3 over 2, not including negative 3 over 2, union 2 to infinity. So as an inequality, we could say that x is less than negative 3 over 2, or x is greater than 2. And that's it. Now let's say, for example, if it was less than 0 instead of greater than 0. In that case, we would have this region. So therefore the answer would be, in interval notation, negative 3 over 2 to 2. If, let me just write if it's less than 0. As an inequality, we could say that x is less than 2, but greater than negative 3 over 2. Just in case you were wondering how to write it if we only had this region. But for this particular problem, this is the answer. So just keep that in mind. And that's it for this video. So now you know how to solve quadratic inequalities. And thanks for watching.